You know, I have to say, Moonlight Sonata by Beethoven is a very interesting song to play during a stream. It kind of fits, you know, with the overall mood. It's pretty cool. Hello everybody, welcome to SkyTour LiveStream on this wonderful September 17th, 2019. We are currently looking at the Trifid Nebula, which is right here, as I will show you. Okay, this beautiful nebula is in the southern sky in Sagittarius, and this is a 20-second exposure. Before we get going though, I want to say hi to KDQ and say hi to Mary Grace. Marianne Robb is here. Shep is here. Hey man, how's it going? CND Conboy is here, and Daryl is lurking in the chat as well. Marco's here. Hi guys. So Daryl already watched American Ninja Warrior yesterday, I believe, so I don't think we're dealing with that today, are we, Daryl? But anyway, we were imaging the Trifid Nebula, and if Daryl's looking in chat, he can see it for himself. It's really quite beautiful. Oof, oof. Can't deny that that's really, really pretty, you know? And what I'm going to do is go back and forth because I'm trying to acquire more imagery of it. I'm doing 20 seconds at 25,600. And I installed a new camera monitor in the dome today. You can see it over here. Here it is. Full infrared system that's able to watch the telescope at all times. I love it. So really cool. It's getting a little chilly here, Shep. Yeah, I got a sweatshirt on, which stinks. But you know what? It's not bad. Okay, that one didn't work. Most of the images are coming out great, believe it or not. I've had no troubles whatsoever. You know, and I missed that. There we are. So basically, hang on. I didn't have the Dome Ops camera facing in the right direction. So what we're doing right now is we're actually just trying to get a little bit more of the Trifid Nebula. The Trifid so named because it has 3 separate lobes, as you can see in this image, which I'll show you momentarily. Here we go. Not this one in particular, but this one. This is a better shot. Really looks beautiful. North Carolina's got clouds. Yeah, that's unfortunate. We've been lucky. We're sort of in between clouds, and we have low moisture content in the air. Thus, we can see really delicate detail in the Trifid Nebula here. See that? Just incredible. It's really, really nice. Very pleased with it. And you can see that things have changed on the screen. We got a little pointer now, not a finger. Little improvements, you know. And so I can go back and just continue to do more, and then we go back. The Trifid Nebula is an interesting location because when we look at it, we see that it has. Oh, there's the hand now. We see that the Trifid has this 3 lobes, 1, 2, and 3, seemingly separated by this black stuff. Okay, this black stuff is actually very dark. Let me just do this first. There we go. It's separated by this stuff here. This is actually dark dust between us and the bright nebula behind it, which is what we're seeing. All right. So when we zoom in on this, you can actually see a little more detail, and you can see that it has some really nice convolutions. Now this has previously not been this good here. This is all brand new, and it's just spectacular. I love the way it's looking now. So I'm going to go back, take a couple more shots. I've taken about 15 already, maybe 20 before you guys came on, because I wanted to give you the opportunity to see what this looks like. it's just really pretty. Hey, David Schmidt. Good to have you here with us, as always. David, I'm still interested in teaching that class for you. You let me know what you want it to be about, and I will take care of it. Let's do another shot here. See, the Trifid Nebula is right by these two stars here, and these two stars are responsible in part for illuminating that nebula, and it's really quite a beautiful nebula. Basically, you can see how incredible how the nebula actually looks. It's got this beautiful red. Okay, and this red, of course, is the hydrogen alpha that we're seeing. Hydrogen alpha is the glowing hydrogen gas that occurs as a result of these stars that are sending out copious amounts of really hot radiation. And this hot radiation will cause the stars to, or cause the gas to be excitable, and the electrons on the hydrogen atoms jump right off. That's called ionization. And they spontaneously recombine and join back up with the atom, and when they do that, it ends up giving off some light. Anytime an atom particle loses energy, it gives off light. Anytime it gains energy, it sucks up some light. So it sucks up high energy ultraviolet, and then when the electron pops back into the atom, it loses some energy and gives up a characteristic red light. You might also notice a blue thing up here. This blue thing is a reflection nebula tied to this star, which is not as hot as these stars. So we actually get this wonderful red and blue nebula right next to each other. It's really quite beautiful. Just stunning. Okay, and then the beauty of the Trifid Nebula is that it's sitting next to the lagoon, which we're going to look at next. And the lagoon is really, really stunning. Oh, Mark Rose, thank you for joining us anyway. I'm sorry you have to go so soon, but we'll hold a spot for you. We'll always have a light in the window at SkyTour LiveStream. And good to have you here. All right. So let's take a look now. Let's go over to our wonderful planetarium program and look at. We're going to drop down now to this location. This is the Lagoon Nebula, right below the Trifid, as you can see. Trifid's there, and here's the lagoon. You can see the indicator for where the scope is. And now we're going to go, and as we do, you'll see the indicator for the scope moving, because that telescope is now moving down that way. And as you can see, we've pulled in, and if we look at the telescope, you'll see the telescope has been moving. You can see the barrel of the telescope moving. And I'm going to just bring up the telescope control and bring us just a little bit south, kind of about like that much. And now let's set it up for a nice 20-second photo, shall we? So this is 20 seconds at 25,600 ISO. Let's see if it works. It's really beautiful. Daryl, are you noticing how beautiful the night is here? Oh, look at the lagoon. Holy cow. That's beautiful. Look at that. That is just gorgeous. Yeah, there we are. Wow. Okay, just a little more movement, and we shall be okay. I'm going to move a little bit to the east. Okay, and a little bit south. And we should see a change. And we do, but I gotta make it a little more. Okay. Good. Okay. And now we'll do that and take another 20-second shot. I know, Daryl. Daryl says it's better each night. It really does look that way. Oh, I know. I can't wait for the dark of the moon. The new moon, as Daryl says. Yeah, the new filter is really very impressive. Hello, Daisy and Zoe. Nice to see you here. Holy cow. Wow. I am just beside myself. This is really beautiful. Look at this sweeping, beautiful nebula. This is the Lagoon Nebula, powered by this star right here. You can barely see it. It's an O-type star. And I'm going to bring us over. I'm going to take us back to here for a second. And gonna raise us up just a little bit. I want to go up, bring us south just a tad. And I go east a little more. So now we should be pretty well centered. This is going to be really pretty. I'm going to do a jog. Okay. Now let's go back. Hey, Dalai. Yeah, huh? This is really magnificent. It's beautiful. Okay, Daryl. We'll see you later. Now let's go in and see if we can see what's going on here. The lagoon is just stunning. This blue background is just it's just a little bit of the sky glow. Oh man, look at this. Will you look at this? This is beautiful. This is something we've just never seen before here. We've never been able to capture this entire extent before, and now we can. David, I think maybe your volume is down, or maybe something's not right for you, I think. But give it another shot here. Look for your speakers, or plug and unplug your headset, anything to help. We'll bring this in. I'm sure it'll bring it in. I'm beside myself here, guys. This is just so beautiful. Wow. Look at this, and as we zoom in, you can see the central part of this nebula. This is a true star-forming region. This little area right here is called the hourglass, okay? And it's this little guy right here, this little hourglass-shaped figure right here. The hourglass is a location where there's very hot stars, and these stars are very much powering this nebula. I'm glad, Davis. Yeah, I figured it was something that simple because, and senility's not setting in with you, of course. It's just that sometimes we forget the simplest things, and I am probably guilty of it a lot more than I am willing to admit. Oh man, this is gorgeous. So let's go back here. Telescope's doing well in the dome right there, and now we're gonna go off and do another 20-second shot here. And let's go and be ready for it. I'm so excited. This thing is looking beautiful. We zoom in on it, and this picture will be replaced by the new one when it comes in. So you'll see it swap positions, and if it looks the same, it's a good thing. It may move a little bit. There we go. See that? It moved just a little bit. But boy, look at that, huh? Wow. I don't know. I've never really do another one. I've just never really had a night like this. I had one night like this last year, if you recall. We've had now 2 or 3 in a row now. But you'll notice these stars. These stars are, some of these have formed in the cluster here. These here, this is O star just there that you can barely see. It's powering this nebula with its ultraviolet radiation, which is overpowering the electron and the hydrogen atoms that are in this neutral gas out here. And the electron jumps off the atom and then spontaneously collides with other particles out there, then recombines with the hydrogen atom. Because remember, they're positive and negative. The proton's positive, the electron's negative, and it loves to topple back into the atom. And they go to every single location. There's energy levels that are discrete energy levels, which is why quantum mechanics is called quantum mechanics, because the atoms, particles go to discrete locations, and those are known as quanta. So when we look at the atoms, the electrons jump back into the atom at a variety of levels, but the predominant level is down to a location called n equals 2. The number of the level is 2, and that's the location where the predominant number of jumps is made to, and thus the predominant color we see is this reddish color, which is the hydrogen alpha that we're so familiar with. Now let's go back to this for a second and just click it and get the exposure going again, because I'm a glutton for punishment. I want to see more and more of the Lagoon Nebula. This is measure 8 of the lagoon, and let's take a look at our planetarium. Okay, the Lagoon Nebula is a beautiful nebula, and it's going to be several thousand light years away, and you can see in its placement in the sky, if we look at it in terms of where the constellations are, okay, or if we look at the mythology, you can see Sagittarius, the archer, here, and it's starting to end up in the southwest now. Here is the summer Milky Way, which courses all across the sky, and we'll be playing up there perhaps in a little bit. But we're going to take a look at some of the things down here too tonight, because we don't want to leave those out, you know. Hey, it's Keith. How you doing, Keith? Weird guy, welcome. Justin T, what's happening? Yeah, so we're actually having some more fun. We're looking at the Lagoon Nebula, like I said, and the lagoon is right down here, and it's near Sagittarius the Archer. This is what's known as the teapot of Sagittarius. Here you can see the handle, see the teapot itself, and there's the top, and here's the spout. But Sagittarius is not a teapot. This is actually what's called an asterism. It's just a set of stars within the teapot, or within the Sagittarius constellation, that resembles something else. Just like if we were to spin around and look into the northern sky, right, we would see the Big Dipper, right, and the Big Dipper is actually right here, right? Here's the Big Dipper in the northwestern sky. Okay, but the Big Dipper is actually an asterism, that is a pattern of stars within another constellation known as the Great Bear. Okay, that's Ursa Major, and the Big Dipper is just a pattern of stars within it. Okay, and then of course we have the Little Dipper here, or the Little Bear, and there's the Little Bear. What a cute little bear. Okay, so those are asterisms, and asterisms are not constellations, but they are actually very helpful in learning the sky. Right, so we come back now, and we have our telescope pointed at the beautiful and amazing lagoon. Okay, and there it is. Look at that. And we just took that picture, folks. We just took that picture, and it's beautiful. I'm going to go back now to here. Telescope is sitting in the dome. You can see it. Let me just get rid of this. Telescope sitting in the dome. You can see it over here. I have a new dome camera that we're looking at here. Don't need that up there. I don't know why that keeps coming back. All right, and let's just take another picture now of the lagoon and head on over to view it when it comes in, a 20-second shot. And that shot, as I said, will replace this right here. And we'll see it. So if it's exactly the same, you won't notice anything, but it'll probably have shifted a tiny bit, because they do that from time to time. Great Bear and the Teddy Bear. That's right, Daisy. Daisy and Zoe Amethyst. It's a great name. So yeah, there we go. There it is again. It's just stunning, you know. Okay, and once again, things come up that I don't want. It's called hitting the function key and not the alt key. So cool. So, if we go back to our planetarium, all right, There's a lot of things to view when we're here, and I want to see them all. I want to go everywhere. David Schmidt asks a really interesting question. He says, do the colors of the nebulae correspond or represent the colors like we see in the aurora borealis? Green, yellow, oxygen, nitrogen, violet. Actually, I'd like to say that's true, but we can only make a very, very loose association. The colors that we see in the lagoon, for instance, when we go to the lagoon, which is right here, and we got that picture that didn't quite come out, but let's look at what it did. When we look here at this picture, okay, this is an example of it's an example of a point in time, for instance, where the lagoon is got a lot of hydrogen gas in it. The stars that are in here have not pushed a lot of this away. Hi, Cindy Murphy. And so we end up seeing that the lagoon still glows red, and that's hydrogen, okay, not oxygen like we would see here in our upper atmosphere for the sprites that we see, or nitrogen, which glows green, right? The green in the aurora borealis can also be due to oxygen. But when we look at it in terms of a nebula, well, it's more of a blue-green. It's what's called a forbidden transition. It's a transition in the atom where the electron goes to a certain energy level that isn't seen in high densities, when the atoms are in high density. That's called rarefied gas, and that's what is required to make some of these atomic transitions that we see. So this, I'm just going to run over here quick and click it. So when we look at the lagoon here, what we're seeing is all hydrogen gas for the most part. And earlier, when we took pictures of the Trifid Nebula, which is here, okay, this is hydrogen gas as well, okay, that's been ionized. This, however, this blue that you can see faintly here, okay, this blue is the result of just reflection off of dust grains. And the reason that the reflections happen like they do is because of the fact that the blue light, okay, and technically, if you want to say it's a reflection, it's scattering, okay. So they're blue. Those nebulae are blue for the same reason that the sky is blue. What's happening is the light is coming in. It's very energetic, and these dust grains are in the way, and so the light hits the dust grains. The dust grains are very efficient at throwing off the blue light, but not really affecting the red light. So most of the light gets to us, but the blue light is scattered in all directions off the dust grain. So we see this nebula, and it's called a reflection nebula, but it should really be called a scattering nebula. But the terminology is reflection nebula. So, maybe a little change in terminology would have been a better idea for that. But it's just that's what we call it. So blue is reflection nebula, caused by the scattering of starlight, and red is the hydrogen alpha. The aurora borealis is sort of greenish blue and sometimes red, even pink. And they're for very different elements, okay? Oxygen and nitrogen are causing those in our atmosphere. But thanks for that question, Dave. That was very good. Hey, Dr. Mark in Texas, how are you? It's so good to see you here again. I know that you've been wrapped up with your practice in Texas. How are things going down there? I'd love to know. I'm doing better myself. I'm doing my best to recover from everything that happened to me. And I just got back from Norway and then Arizona, where I had to go speaking in both places. And I'm probably going back to Sweden next month, maybe, to talk there. And then when I come back, I'm going to Arizona again to talk there. So it's like, it's pretty crazy. So we're looking at the Lagoon Nebula, as I said before. And it's really extensive, really has a lot of dark lanes in it. You can see a lot of these dark lanes are very, very prominent. And after I process them, I promise you they're going to be even more prominent. So let's check out our planetarium program and let's see what else we might actually see here. Let's go over to, let me pull away a little bit. I want to go to one particular location, but I might have to actually move the dome a little. I've been focusing on this one spot. This is kind of near the Sagittarius star cloud. Actually, let's go here because this is a very interesting location just to look at. You want to see stars? I'll show you stars. Okay, this is the stars you want to see, okay? Now, you don't really see too many. You can see the telescope's moving over to them. Let me just make sure that I can show that to you. There we go. Okay, the telescope is moving. We should have no problem viewing this. So, we don't see too many here, but let's do 20 seconds at 25,600 and just see what we do have, shall we? I have a feeling that you'll discover, like I have, that there are many stars that go unnoticed. And let's count the stars that may look a little red, shall we? Because that's another one that I like to do. Hey, Cypher, how are you? Good to see you here. Illuminati's Mysterium. Taking a little drink of my iced tea here. This is to help keep my voice going. Look at this. This is the Sagittarius star cloud. And I got it right here because this is sort of on the edge. This is kind of an area where there's some dark nebula here. And then you actually see the beginnings of many stars. And it just goes, it's really beautiful here. So this is, let me trying to show it to you like as a whole. So you can see there's a lot going on here. And if I actually, let me just go in and let me take the filters and let me play a little bit here. Give us a little bit of a different view here. Let's try to pop this over here. You can see I could change the colors drastically. Sometimes by changing the color, we can actually see other details that we might otherwise have missed. Not in this case. In the case of nebulae, we do, though. Okay, let me just pull this back a little. That's good right now. But you can see that that's actually pretty cool. And then that's what it looks like normally. And then with a little bit of processing, it's not quite what I wanted to do. A little more. A little more, a little more. Yeah. Maybe like that. Maybe like that. Yeah, it's a little better. But you can see this rich abundance of beautiful color. It's just really, really pretty. Hey, Daggers. Hey, Tim F. You are late. Normally you're like one of the first ones. That's cool. So let's go over now, and let's just take our view here and actually go to my planetarium program. Let's move us over just a bit to here, so we'll have NGC 6603 in here as well. We'll see Gamma Sagittarius down here. That's the little Y. That's the Greek letter Gamma. All right. So we'll move to this location, and you'll watch the little crosshair of the telescope move over. Zip, there it goes. Okay. And then when we take our picture of this, then we will now see a little bit of a different view. We'll actually see the star cloud in more detail. You ready? Here we go. 20 seconds, off and running. Very nice. Okay, and we'll wait for this to come in. It should be here momentarily. Look at that. And you can see the NGC right there. And you'll notice that the NGC has a really interesting asterism in it. Okay, it has this asterism. It looks like a line of stars. Like they're perfect. You see that? Yeah. And you might say, well, geez, you know, is that actually something that's, you know, intentional? Is it, you know, is it the way the universe works? How does that work? I'm glad you're here, Tim F. Thank you for coming along. I know you said you were late, but it's okay. Wow. Yes, sirree. Well, the answer is that's how the universe works. Sometimes we get these chance alignments. So we see things like these stars lined up right behind each other. And it looks like a perfect line. And our mind makes them into a perfect line. But actually, when you measure these directly, you'll find that they're not quite lined up at all. But we try to find order where there is none sometimes. And we actually create the order. You'll notice also that some of the stars are a little bit more red than others. In fact, if I go to the normal colors here, you can actually see that this star is a little more red, as is this one. This one's very blue. So, you know, and this is interesting. You got an orangey star here with a blue star next to it. It's really kind of cool. And many of these are double stars. You know, stars that are truly double stars. But boy, this is just beautiful tonight, you know. So I want to take us now to our planetarium shot again. And let's zoom out a little bit and find a place to go. I may have to move the dome if I want to go anywhere over here. I don't necessarily want to, but I may have to. You know, there's some of these wonderful places, but these are also very low in the sky now. See, this is the horizon. So we're pretty low in the sky for these. So it behooves us to kind of look up here somewhere. Now, I may not be able to see this tonight, but it's an H2 region. It's a region of red nebulosity, nebulous nature that's associated with this cluster here. And I want to see if we can actually see it. All right, so we can also go to the Omega Nebula shortly thereafter, but let's just try this real quick. All right, so you'll see the telescope moving. All right. Yeah, you can't see that right there. It's all right. Okay, and all right. So let's bring this up a little bit. And we'll move a little joggy-rooney. That's an official term, joggy-rooney. Let's take a 20-second photo at 25,600 and see what we get. Oh, yeah. You know, on nights like this, guys, I don't know. I can't imagine, you know. Hey, Jax. I can't imagine just sitting around doing nothing, you know. I can't. Just can't. Oh, we have a dome problem, darn it all. Dome has to move. Which is kind of too bad, because I was hoping that I wouldn't have to. But you know what? It's okay. I'll run out there. I'll leave you on the Sagittarius star cloud. I'll run out to the dome and just move it. And you may ask, why haven't I motorized it yet? Well, I haven't motorized it because I'm going to get rid of it and put in a roll-off roof observatory. So I'm not spending the time and effort and money to motorize the dome and the shutter that has to open and close. I'm just going to have a roll-off roof that rolls off once and rolls on once in the middle of the night. You know? So I was looking at some of them today, actually. I was up at a exposition, and there was a lot of these buildings out, and I wanted to see what they look like. And I can get one for just a few $1,000s. I know that's a lot of money. It is for me, of course. And I'm not trying to say it's not. But for a few $1,000s, I'll be able to get what I need. And then, of course, turn around, take a saw, rip it apart, and make it into a roll-off roof building. Yeah, it's crazy. You buy a brand new, perfectly good shed, and then you rip it apart. Anyway, I'll be right back. I'm going to go move the dome. If you have any questions, go ahead and leave them, and I'll read them in the chat when I get back. Okay, I have returned. I returned, and we're preempting what I was gonna look at, because I noticed something interesting. I noticed that we have another object that we haven't seen all year, and I think it's time that we take a look at it, don't you? And you may not know what that object is, but I do. So I'll tell you right now, you'll see it. So let's get this going. So we actually have moved significantly around in the sky. And as you can see, the moon has risen. But I want to take a look at the Andromeda Galaxy, don't you? I thought so. So we're going to go there. And we shall see the movement occur. Okay. Here it comes. All right, hang on. We'll be right to it, hopefully. I noticed I had a little... All right, here we go. There we go. All right, let's make sure the telescope is pointing the right way. Yeah, see that? Telescope's pointing right out the dome. That's beautiful. Yes, David. Question. That's one way, David. Yes, he asked the question, can a star's distance be determined from its light only by measuring the parallax at different times of the year? Well, what's parallax? Parallax is the relative change in position of the star against more distant stars, as seen from either side of the Earth's orbit when we take a photograph of that star. And that's one way. I actually worked in a parallax program in an observatory, and we did quite a lot. You know, we actually got a lot of good stars measured up and processed. But the fact of the matter is, we need to use different methods when we're looking more than, say, 300 light years out. I'm going to set up for Andromeda here, but I'm actually going to increase using the 4K mode. As you can see, Andromeda's right here. It shows up very brightly, so I can bring up my 4K mode and move Andromeda into the view. This is all the way across the sky, so for it to show up in the view is quite remarkable. Well, not really. I have good equipment, but you know, it's only as good as how much you maintain it. Okay, so Andromeda's ready for photography. And I'll take us down from 64,000. The moon is up, so I'm going to try and drop us down to, say, 16,000 for 20 seconds, okay? And we're going to take a shot of the Andromeda galaxy, 2 million light years away. Here we go. We're off. Cool. Let's see what we get. So, if you're looking using parallax, you can get out about 300 light years. But if you want to get out further than that, then you need to use other things. And some of those other things include looking at these variable stars called Cepheids. And Cepheids are a strange type of star because they are, wow. Might have a little bit of the dome in the way for this one. Cepheids are interesting because they are stars that are variable in the way they pulsate, but their pulsations, their period, the time it takes for them to go from dimmest to brightest, that period is directly related to their intrinsic brightness. And knowing the intrinsic brightness of a star, that is the brightness a star would have if you were looking right at it in front of it, and the brightness that appears in the sky, knowing the difference between that intrinsic brightness, called the absolute magnitude, and its apparent magnitude as it looks in the sky, we can tell how far away it is. So that's a little secret key to understanding the Cepheid variables, and those stars give us distances. For instance, to the Andromeda galaxy. This very galaxy, we discovered the distance using Cepheid variable stars whose pulsation rates tell us exactly how bright they are and thus their distance for the Andromeda galaxy, and it worked very well. Dagger spells. Your parents were in NORAD, huh? Cheyenne Mountain, is that right? That's pretty cool. Pretty cool indeed. Okay, so let's go back here. I'm going to go to 20,000 now. And take this photo. Okay, and now this is a little better photo. I do think the dome is interfering just a little bit. You can see this dark lane though. We also have moonlight interfering, unfortunately, and I'll warn you now, I'm going to take us down to look at the moon. Why not? So when we go to look at the moon, just be aware if you're looking at it in a dark room, it's going to be pretty bright. Okay? So you'll see, here goes the telescope migrating its way down. Okay. Oh boy. Big, bright boy. Okay, we don't need all this ISO. We don't need all this. Oh, look at a plane going through. Wing by. Wouldn't that have been funny if it were right in front of it? Okay. And I'll bring us over. I can't tell you enough how much I cannot wait until I get my telescope down in Arizona. I cannot wait for that. Okay, we got a little thing going on there. What is that? I might have missed something in my reconfiguration here. Got a little area down there that I don't like. That's cool though. That's the moon. Okay, let me just fix something here. Just a minute. I'm going to fix something that I'm noticing here. I don't like that. I just got to pull this in. I don't know why it's doing that. Okay, I'm not certain of what was going on there. But it did what it did, and it's out of the way now. Okay, so here's the moon. We're looking at the moon. So the bane of astronomers. We don't like seeing the moon. The moon is purple because of our filter, by the way. That's why it looks the way it does. Right? And I should knock down the values there. We can actually take the moon here from this particular location. We can actually go in and mess with the colors in the moon here a little bit. And we can try to do some other manipulation of the colors. There we are right there. Let's try this. Usually when you buy a new telescope, see this is kind of like the normal moon, a little bit in this realm, but usually you get green filters for the moon, and people say, "Oh, green cheese! The moon's made of green cheese," you know. And yes, I understand that, okay, but that's not what this is. You can also see how still the night is by looking at this to see, you know, how the craters look. You know, I can do some more work on those. Yeah, we got some artifacts there. Okay, and we're really zoomed in tight here. Let me go here and go into my filters again and mess with this a little more. Also do that, sharpen up a little bit. Yeah, you can see the digital dancing, I call it, you know, it's just kind of neat. Digital dance. We can also go to black and white, where we can really oversaturate and shift the colors. So this is kind of more like the moon we see. Like that, okay? And you can see my colors, even the controls, because it's hitting all the controls, not just our view of the moon itself. So, but we can take a look at colors now. Let's do this. Let's shift our hue back. Let's actually go to defaults. Okay, there we go. That's pretty close. Very cool. And we can also be looking for things across the moon. It's sort of like satellites will move in front of the moon a lot. We've seen those many times. This is a view I normally use for focusing, but I'm, I can turn it on and off, but I turn it on to actually kind of focus on one section of the sky, give us a little bit of a section of the sky to look at, to help focus. But right now I'm using it to actually look at the moon for some details. We're not P&K Space Imaging. That's Keith and Paul. We do the deep sky stuff. So we don't see the moon in the best way possible. They do. And that's why I like to let them, that's for them to do. They have the corner on that market, and I'm all for it. We support each other. But let's see now, if I want to go and look back here. Want to go see Uranus? Let's go see Uranus. Here we go. So we're going to leave the moon behind. And we're going to go to the planet Uranus. And to see it, we're going to want to increase our ISO. And take longer exposures. Oh, look who's creeping in on the left side there. I wonder who that is. I'll bet you we know. I'll bet you we know who that is. Okay, and this is, of course, let's do this. Let's zoom in on it a little bit here. Just a second. It's coming back. Don't worry. All right, I'll bring it back here. I've got what I'm trying to do is just bring it back into the view here. So see, it's over there. So I'm gonna bring it back in. Okay, and let's see if we can grab it here. Yeah, okay, I'm not finding it here. That's all right. Well, first thing we should do is just take a photograph of it. So we're going to do that. Okay, so there it is. My, no wonder I didn't see it. That view was shut off. Okay, and here it is. Okay, this is Uranus. One planet before Neptune. Sitting out there. Yeah, there it is. And you'll notice it has an interesting color. It's sort of a cyan color. And besides, it's very, very small. I'm going to take it, I'm going to drop the ISO down here. and then go down to say 250 and drop the exposure down. You can see how much smaller it's getting. And we're going to take a picture right now. It's 1 second exposure. And there it is, that little tiny, well, you can't even see it now. That little tiny dot, there it is. And let's zoom in on it to see what we got. It's actually, you can see, Uranus is somewhat, it's somewhat featureless, isn't it? You know, and it always has been. I mean, it's never had a tremendous amount of features to it, which is kind of interesting. But Uranus is still, it's still pretty cool in of itself. You know, it's still pretty cool. It's a cyan color. You know, you can see the colors there. It's actually got that kind of a bluish color to it. Uranus actually has rings and a lot of moons. So I mean, it has a lot more going for it than we ever gave it credit for, didn't it? You know. And the thing is, it takes. Let's see. Oops, I don't want to do that. It takes quite a while for Uranus to get around the sun. You know, I'm trying to find some of the other. You know, it's actually it's 19 astronomical units from the sun as opposed to Neptune's 30. So you can see the vast difference in distances between Uranus and Neptune. Really incredible, you know. But it's really quite near the moon, so we're not going to really get the best views of it. What I would like to do, though, is to see if we can look at the Triangulum galaxy while we're here. We're kind of rushing the season here. This is not these galaxies are not in prime position really at all, especially with the moon up. But, you know, we're going to try anyway, you know. So here we go. Let's give ourselves a lot more ISO. You can see the stars pulling in as we increase that. And I'll take us to 12,800. Okay, and we're going to set this to about 15 seconds initially. And we'll see some blue scattering of light based on the fact that the moon is up. Okay. So there we go. Hey, Bobby Burgess, how you doing? Welcome. Okay. So now, with this setup like this, I'm actually gonna take us down a little bit and go eastward a little bit. I may actually have to go back down because I might actually, on this side of the sky, I might have a little bit of a difference there. But either way, we gotta jog ourselves this way and take our 15 minutes of fame. Hey, Carolina. Thanks for dropping by. Good to see you. Gas mask. Waldport, Oregon. Is that where you are? Wow. Let's see here. Yeah, it's down here. Let me pull us up. Let's bring it up. Because even though it's lost in the lunar glare right now, there is an interesting reason for us to check it out. And I'll show it to you. Let's go to 20 seconds. Okay, 20 seconds is almost up. now it's over here. I neglected to remember that it's flipped on its side. So that's one of the problems I have sometimes. It flips on their side. So let's do this. Let's go in here and do a little bit of a manipulation like this. And try and bring it where it needs to go. And if you're like me, you're saying, where the heck is it? And we're going to try that. I may or may not have gotten it. I couldn't really tell where I was looking at the moment. But it's all right. 20,000, 20 seconds. And I don't care about the drift if the telescope drifts right now. Yeah, there's a dome issue as well, Shep. Hey, Jim. Welcome to SkyTour LiveStream. Glad to see you here. We're taking photos of Messier 33, the Triangulum galaxy right now. We got bright moonlight, though. So it's unbearably difficult to see right now. Unbelievable. Okay, here's what I'm going to do. I'm going to go over here one more time. And I'm going to tell my computer to go search for it in the database. So now I'm going to find it again. And now it should end up being, I think, either here or here, depending on how it shows up. So we're just going to do a little bit of a jog this way and then that way. That's only because I haven't corrected for backlash yet. And do a 20-second photo. D. Smith, did I say hi to you tonight? I'm sorry if I did not. But hi, D. Smith. What's going on? Yeah, it's right there. You can see it right there. Extremely faint, especially on a night like tonight. So it's really not worth looking at, you know. That's faint because the moon is up, okay? And that's okay. But we have many, many galaxies in this region, without a doubt. Andromeda's got lots of galaxies in it. And of course, along with the Andromeda galaxy itself, which you see right there. So there's plenty to see. Now, we have rising right now down here. Winter is cometh, folks, and here come the Pleiades. Pleiades has risen. It's way down low. For me, that's behind trees on my horizon. Can't see it yet. But this was Pegasus, which is the Great Square. And the Great Square is an asterism that is a pattern of stars within the winged horse of Pegasus, the constellation. So that's pretty cool. And then overhead here we have Cygnus, the swan. And again, the night is beautiful, but I'm noticing we have more moisture in the air tonight. And early we did not, but tonight we actually do now. It's showed up more. Hey, Tana, welcome. Good to see you here. So, what I'm going to do now is I'm going to try and get some more of the objects here for us to check out. And to do that, I'll have to go move the dome again. Lucky you. And maybe we can check out some of these things. They're really low to the horizon. But with the moon up, there's really not a whole lot that we're going to be able to actually see. What I am going to do, though, is I'm going to take us to the dumbbell, and then I'm going to tell the telescope to go there, and it won't be able to see it because the dome is in the way. But let's just go anyway, and then see what we get. Because I know that we're going to see stars for a bit, but then they're going to probably go away because the dome will be in the way. And how will I know that? Well, I will know that because I will be able to I'll be able to check out whether we have actually I gotta just a second here. I'm going to start up my camera again. Yeah, well, I don't know. It might have worked. Let's find out. Might have worked. I'm not sure. I changed systems, so it's a little bit tricky right now. There's a few things going on here. Trying to improve everything here, actually. All right, well, maybe this worked. So what we're going to do is go to the remote view. Go here. I want to take color correction and go back to defaults. All right, good. All right, so now we're going to do a 20-second photo at 20,000 of the dumbbell. Actually, not 20,000. We'll do 16,000. But first, I'm going to go into 4K mode and make sure that the dumbbell is close to centered. I think it's over here. I believe that's it. Yeah, it is. Okay, so now what I do is I shall bring it over. Okay. And then bring it up. Here we go. And now we're ready to image this object. The dumbbell is a planetary nebula, that is to say a star that has finally shed the mortal coil. It is dead. It has died, leaving behind a very hot white dwarf. And I'm going to take a photo of it for 20 seconds at 12,800 right now. Here we go. I'm not sure if the telescope will have drifted a little bit. I do have some drift going on lately, which is no fun, but it does happen. Okay, we took the Andromeda Galaxy earlier. We had a little dome issue. And right now, I really think there should be a little bit of a dome problem, but we'll find out. Apparently not. Look at that. Here's the beautiful dumbbell once again. And the dumbbell is one of these nebulae that just never gets old, you know. It never gets old. It has beautiful colors. Those colors are the colors of oxygen, hydrogen, and neon as well. Neon. Pretty interesting, huh? So the neon is one of those things where the color is actually okay, that's good. Neon is the responsible for the reddish colors around the outside edge. Okay, just stunning. But we have the moon up and water vapor, so it's kind of hard. So tonight's not as good a night as the other night, which is sad because it was really beautiful the other night. You know, really, really stunningly beautiful. You know. Yes, sirree. Wow. Okay. Well, I wanted to do a quick survey of tonight's stuff, and I'm going to stop the stream because I'm going to start doing some research stuff for myself, and I don't want to bore you with that. You might find it interesting, but I wouldn't be on the mic. I would be doing all kinds of crazy things. You wouldn't know what the things were I was looking at. So I'm going to end up killing it now and then doing some more research for myself. But that's okay. I will be coming back. I also have some housekeeping stuff to do. I've got to make sure that I can get these windows all set up the way they need to be set up. David Schmidt, I didn't talk to you directly about when we might do this class for you, but I would like to do that, and let's do that soon, shall we? So let's talk. I know I've only gone about an hour and 15 minutes tonight, but to be honest, I have to be up early tomorrow as well. I got members of the town coming out here. I guess they don't like my minions on my front lawn. I got these domes out there. I've got 2 of them out there now, so it's a little bit crazy. It looks like Dolly Parton sitting on my front lawn. But it's because one of the domes is actually, I've donated it to a Tennessee school, and I'm kind of getting it prepared for shipment. So it'll be interesting. All right. Well, my schedule, David, is anytime. I just, as long as it's, well, I should say anytime. Anytime it's clear. But you also have to give me an idea of what you might like to have us talk about. And I say us because I thought that maybe Daryl and I would do it, or Keith and I. I'm not sure. I forget who we talked about doing it with you. It might be Keith. But Daryl, of course, is very welcome to do it as well. He's done public outreach before in astronomy. But you let me know where you are in an astronomy unit, or if not, where you might be. If you want to arrange it to be like a school-wide presentation on a big screen, you feel free to do that. That's funny, you weird guy. Yeah, in Australia, they keep their downs out back. Let me know, Dave Schmidt, where you want to do this. If you want to, like I said, if you want to do it school-wide, maybe you might want to, talk to the school and maybe assemble all the students together and have a special program. Happy to do that. We've done that. I do that all over all over the world now, because I can. I couldn't say that before. But I really would like to help you out as best I can. Oh, and Shep, I'm glad that you see. I'm glad you see me out there. That's, I'm the voice of reason, I think, in the UFO world anyway, because I believe that they could be here for sure, but I don't necessarily believe everything we see in the sky is a UFO. I get that a lot, But I've been on a lot of the shows as True Shep, so I guess they like hearing science. That's what I take away from all this. That they really want to they do want to know the science as well. Very pleased. I just did an episode of Contact. Actually, the final episode of the first season I did out in Los Angeles on Discovery Channel, and then did a Travel Channel, about 5 or 6 episodes for a new Travel Channel show while I was there. And of course, What on Earth and NASA's Unexplained Files, which has not come back yet in terms of reruns or actually shooting new stuff. So it may be, hey DW, it may be that show was run its course. I'm not sure. But What on Earth is still out there, and I keep getting requests for more shows, which is interesting. So it shows that people really do want to hear what I would call a considered approach. An approach where it's fun to talk about, and about UFOs. It's fun to talk about aliens, and I do, but I talk about them in terms of the realities. When we look at, for instance, our universe, and we check out things like the Dumbbell Nebula right here. Okay, when we look at things like this, we say, well, could there be life forms that were around the star that this was before it lost all its gas? Because this gas is really, really hot, but and it's out, well over almost a light year probably. And if so, then you got to think, well, all the planets that might have been in that system are dead. So the inhabitants of these planets either had to escape or they died. So they've had billions of years to figure this out. So I'm guessing that they would have left their star if they were intelligent, So it's just the way it is, just the way it is. But the way it works is that every star you see in this image here, every single star, it's very possible that the vast majority do have planets. And we do know as astronomers that there are more planets than there are stars in our universe, and that counts for every galaxy everywhere. So that is unbelievable to think about. It really ups the chances that statistically that some intelligent life may have formed elsewhere, because we went through this little circuitous path and here we are. We had 5 major extinction events on our planet. Nothing like this though. This is a true extinction event. When we see a nebula like this, it signals, it heralds the end of worlds. Supernovae herald the end of worlds. Black hole collisions and neutron star formation from these supernovae herald the end of worlds. When a star goes to a white dwarf like this one, and where is that white dwarf? It's right here in the middle. Okay, this is the white dwarf right here, right there. That used to be a huge star. Well, not huge, but it used to be a star that was probably anywhere up to 2 to 3 times the size, the mass of our sun. Or it could have been one that was just about the size of our sun, or a little bit smaller, a little bit larger. So it maybe had planets, and those planets were destroyed. Those planets were actually wiped out, made devoid of life when this occurred, because this gas moving out ended up getting heated to very high temperatures. And this ionization that I talked about so many times, then we get this recombination back into the atom of these electrons. These are high energy events. And no life forms based on carbon could probably survive such events. All right. So when we see a planetary nebula, we can only, as astronomers, we see death. We see death. That's all we see. If there were life there, we see death. There's no way anything could really survive that, at least if it's made of carbon. And now you might be thinking, well, what about silicon? We've heard about the silicon-based life. Yeah, you know where that came from? That came from the fact that the silicon atom also combines with a lot of other elements in the same way that carbon does, except carbon leaves silicon in the dust. Carbon bonds with millions and can form millions of different compounds. Okay, and this flexibility of carbon is not even remotely approached by silicon. So yes, you might say there's silicon-based life, but does silicon-based life have that flexibility that the carbon-based life does? And the answer is no. So I'm guessing that because silicon-based or carbon-based life was something that happened here, I'm thinking that silicon-based life probably wouldn't happen elsewhere, but carbon-based life might. It's a template provided by the universe, So that said, these may herald death. These planetary nebula, these ends of stars, we see them as really interesting, colorful things. I see them also as, the herald of the end for a star system and possibly life in that system. And if it was life in that system, it was old life. It was definitely life that was beyond 10 billion years old. So truly, we're looking at the potential for a civilization that may have been here at one time, and same around the Ring Nebula, to have possibly left this star and moved outward. Let's hope they did. I wish for them that they did, if they were there at all. But again, there have been an awful lot of speculative discussions about life elsewhere. I've been on panels. I was on a panel with George Knapp, Chase Kletsky, and Richard Dolan in this past International UFO Congress. And George Knapp, you might know, he's one of the pit bulls of the news and journalism industry. And we were asked about ufology and where ufology was heading. And I felt that ufology is heading in a different direction. It's heading down a path that will be taking science more seriously, because science is not so far off from ufology anymore. If you listen to Michio Kaku, maybe he's watched some of my stuff, because Michio's now saying, these are his words, okay, New York University, Michio Kaku, by the way, he's saying that it was in the past where we didn't really expect that there might be proof of alien life elsewhere. However, now the discussion has changed. Now, the burden of proof is on the government to show that it's not here. Okay? Very powerful words from a tenured professor. Okay? And one who definitely doesn't want to say things that would upset sales of books. Okay? But Kaku is actually saying what I've been feeling for a long time. And I'm going to actually contact him and see if he'll come on either SkyTour LiveStream or on SkyTour Radio on KGRA with me. I'm hoping that he will. So I'd love to have a discussion with him, and I'd like to have him give you his explanation of string theory and why that's where it's at. There's ways to use string theory to travel, which I think are beyond even this warp drive we've talked about before, called the Alcubierre drive. Really neat. Anyway, guys, I really enjoyed talking with you guys tonight and showing you a few things. The moon is up, which means I go down. Okay? When the moon rises, I set. So we will come back again tomorrow night. The moon rises later. And if it's clear, we'll be here again. And this time we will check out a lot of things. David, I see that message. Hang on, I'll get to you. And we'll check out even more. So I'm sure that we will. We'll come back in contact again tomorrow night. So let me just do some housekeeping with Dave Schmidt. You can email me, and this goes for any of you guys. If you want to email me, you certainly can. My email is very simple. It's my email is MUFON Analyst, MUFON. No, I'm going to put it in here. Why don't I just put it in here? I'm going to put my email in here for you guys so you can see it. Yeah, no, that's coming out. Migdulfon. I had my fingers in the wrong keys. Okay, here is my email that you can reach me at. There you go. MUFONanalyst@gmail.com. If any of you have questions, you're like family to me. You guys are viewers that always come back. You have access. You can write me. You can talk to me. You have questions, I will answer. I believe that science is reachable by everyone. And so make sure that you don't hesitate to ask. It might take me a couple days to get back to you, but I will get back to you, because I really love hearing your questions, and I love giving you interesting information that you can then take to a whole new level. Okay, so there you go. Enjoy. Contact me as needed. Dave Schmidt, that's my email as well. And we'll set up a class for your guys over there in Bangkok. And we'll go from there. But folks, until then, I will talk to you a little bit later. Remember, keep looking up. And remember that this universe is full of life. It's the norm, not the exception in my view. All right. So, thanks, Daggers. And I will talk to you guys later. And we shall be back tomorrow. Good night, everybody.